WMPG Community Radio is supported by its listeners and by Brad and Wyatt's bike rental on Peaks Island. It's 4 miles, less than 1 hour, to pedal all around the island. The natural beauty of Peaks and cafes and beaches are accessible by bicycle. Brad and Wyatt's bike rental is open 7 days a week from 10 to 6 and can be reached at 766-5631.
You're listening to WMPG 90.9 Gorham, Portland, Southern Maine Community Radio from USM. Live from the Orion Cygnus arm of the Milky Way galaxy, this is Scientifically Speaking, a weekly half-hour program devoted to elegant curiosities, and I am one of your hosts, Sarah Chang, and joining me as always is Bernie Rhyme, DJ Starwatcher. How are you, Bernie?
Yes, hi Sarah, very good, thank you.
Bernie is our professor of the astronomy lab at USM and our local protector of the night skies. Reach out to us at WMPG Scientifically Speaking at gmail.com or on Twitter at WMPG and you can head over to WMPG.org to find the last 5 weeks of archives of all of your favorite shows, including this one. Bernie, could you let our listeners know what to expect in the night sky for this coming week?
Yes, certainly. Okay, so today will be Friday, September 3rd. Basically, we'll have a waning crescent moon. It won't be coming up till about 2 in the morning, so it really won't be in the way of anything. The planets are still the same. Jupiter and Saturn, they're both just past opposition, so they're rising actually before it even gets dark, so you can see them in the east, and then Venus is setting in the west. However, this will be an interesting weekend because our own local astronomy club here in Kennebunk will be having its annual Starfest and dedication of our observatory. Someone named Peter Talmadge basically designed it, and he passed away a few years ago, so we renamed it, and we're going to dedicate that, and it's open to the public, so everyone can show up. Hopefully it'll be clear. We start Friday, but it'll also be there Saturday, and we'll probably do some solar viewing in the daytime if it's clear, and obviously viewing the stars at night. So we should have a good weekend coming up there, and the moon won't be in the way, so that's kind of why we do it as close to the new moon as possible.
Awesome. Thank you, Bernie.
Welcome.
And I think the Acadia Night Sky Fest would then be in about 4 weeks as well, right?
Right. They're moving it to the end of September. They used to conflict, but now they don't.
Yeah. What's the address for that again?
Oh, it's it's Alewife Road. It's Route 35 in Kennebunk. It's about 950. We don't have actual number, but there's one bend in the road, and it's about 4 miles out of downtown Kennebunk. It's still in Kennebunk.
All right. Well, thank you, Bernie.
Sure.
And if you couldn't take notes fast enough, you can also check out the monthly What's Up column in the Portland Press Herald. So today's show is piggybacking off of last week's show. If you were tuning in at all, we talked about and kind of dissected a little bit the IPCC sixth assessment. So the report that they recently came out, which is a conglomeration of reviews of all the research that has been done since the last assessment, and all 192 UN nations are a part of this IPCC committee. Looks at human-driven climate change on our beautiful blue planet. And we, Bernie and I, we're just so enamored by this topic that we wanted to see if we could actually talk about one of the rising stars of the greenhouse gases, which is methane. And we've heard a lot about methane in the news and in science news, but kind of diving more into it and seeing if we can learn some new things about methane, where it comes from, how it could be captured and used, and maybe some of interesting things that maybe you might not have known about this molecule CH4. It is one of the most abundant hydrocarbons in the world, actually. And right now we have more CO2 in the atmosphere than we do have methane. And CO2 does absorb energy and it warms our planet. That's kind of been the big thing. But CO2 also only absorbs certain frequencies of energy. And methane, unfortunately, Bernie, I think you have some numbers on this. How much more potent is it as a greenhouse gas?
Anywhere between 50 and 100 times is what I heard. So it absorbs some other frequencies of energy. So that's a good way to put it scientifically. I came across that too. Mm-hmm. That's why there's much less of it. It's like, way less, but it's way more more potent. So yeah.
Yeah, I think some of the numbers that we also came across for the ratio is there's about 400 times more carbon dioxide currently in our atmosphere than there is methane. Methane, if you will, kind of lasts for a shorter period of time.
Right.
It'll break down quicker, but again, like Bernie said, 25 to 100 times more powerful than CO2, meaning it is more powerful at trapping heat, meaning that it could create more opportunities for warming our planet as we release more. And a little bit about that, I know I mentioned the frequencies, but what that means is every molecule, so we've got water. I think, Bernie, water is the other. It technically is a greenhouse gas, water
Yeah,
vapor
water
is.
vapor. It's actually the accounts for the biggest percent, but it's very short-lived. Methane's about 10 years and CO2 is about 100 years. So you
Mhm.
get a huge range. So yeah, it's mostly water vapor, but we don't really have to worry about it.
Right, right. And we feel that when it's, hot and humid at the same time, like
Yeah.
we here in Portland have been experiencing the last, I guess 2 weeks ago.
Yeah.
And that when it's really humid, it just feels that much hotter. And so that's when people talk about, oh, like Arizona, like it's really hot, but it's not that hot.
Mhm.
It's because it's drier heat and it just doesn't trap the heat in the same way that high humidity does.
Mhm.
So every as we mentioned, every molecule can absorb certain frequencies of energy. And Bernie talks about this all the time with the electromagnetic spectrum. And there's, we've got gamma rays to microwaves, radio waves. What's the largest wave?
The longest is radio waves.
Radio waves. And then the shortest so far, gamma. There's probably something more short, right?
Well, officially starts at gamma. I mean, it's like a trillionth of a nanometer. It's
Right.
pretty short.
I feel like they had discovered like even shorter ones though. But yeah, our standard electromagnetic EMS is gamma rays to radio waves,
Mhm.
and radio waves could be like gigantic. I mean,
And the length of the whole Earth.
right.
That's pretty big. Yeah.
And so what happens is light will come in to the earth from the sun. So waves will come in and comes in at different frequencies. And as heat is trying to escape the earth, again, there's lots of frequencies trying to escape the earth. This light, as it's reflected back, comes in tiny particles called photons. And so they travel in these wave patterns and, don't always go straight back into space. They can bump into molecules in the air. And so when they do that, the molecules can then kind of reflect those protons. Sometimes it's just like kind of random, it goes all over the place. But what happens is greenhouse gases can block those photons, but certain molecules can only block certain photons that are tuned to a certain frequency on the spectrum. And so methane happens to be able to absorb certain energies that CO2 and water vapor aren't able to. And what range that is, it can't really tell you specifically, but everything that CO2 can absorb, methane is just beautifully able to absorb those. And so then we have more opportunities to trap this heat, this warmth, these energies in our earth, and therefore contributing to methane. So methane, there's a lot of sources of methane. The earth actually harbors a lot of methane. I mean, back when, earth is 4.5 billion years old and we were essentially all methane. Methane was like a big component in our earth, and then it got captured and trapped. And last week IPCC we did talk about. I think we talked about the permafrost, right, in
Yeah.
Siberia. And so what that means is that methane is under high pressure and cold temperatures, water molecules, so methane in the oceans, water molecules can actually capture methane and that's called like a cathrate. It's essentially kind of a cage of water around solid methane. And so as water's warm, these cathrates can break down, and then solid CH4, solid methane, can break free and then become gas. And 1 cubic meter of cathrate, if this means anything to you, can release 164 cubic meters of methane gas. So it's not, it doesn't take a lot to blow up essentially. And so, that permafrost in Siberia contains a huge amount of trapped solid methane. And so it's this vicious cycle. As we release more CO2 in the atmosphere, ice melts, releasing methane, warming the waters, releasing more methane, and the cycle continues and continues. Um, but we are also contributing to some of the methane release into our atmosphere. Bernie, I think fracking is kind of one of the big controversial ones, right?
Yeah, right. See, and that's kind of interesting in a way because that's actually something we could do about that. Because even a lot of it's happening in western Texas. There's a field there, it's called the Permian field, that used to be an ocean bottom, so it's perfect because
Mm-hmm.
methane is a natural product of decomposition. That's where we get oil and gas from and coal from in the first place. So they're mining that now with fracking, and of course they're injecting all kinds of other chemicals and other things, which is bad for the local water. But then they're flaring off a lot of the methane that comes out, but it's not 100% efficiently flared, and they're losing money. So some numbers go to $34 billion a year. The
Wow.
oil companies are losing just by flaring off this methane. So if they could be more efficient, they could cut down the global warming, the greenhouse gases, and also capture it for energy. So that's kind of a win-win for everyone. It's helping the whole planet, and they themselves know they're losing a lot of money by flaring this because all this extra gas just comes out, and a lot of it's not even visible. There's actually I watched some videos of people going down there with cameras that can detect this, and you can see it. They even showed it to policemen down there and other people. It's almost like having an infrared camera. You can see heat sources in a house.
Oh
You can
yeah.
see the actual methane going from these wells that are not very efficient in flaring them and burning them off. So a
Yeah.
lot of that's going into the air that shouldn't be. It's costing money.
Yeah.
Yeah.
Yeah, that's also the danger of methane. It's odorless and is often only detectable by lighting it up, which is what I think you're referring to when you say flaring.
Yeah, flaring, right? Yeah.
Yeah. Um, the full extent of methane's impacts are still unknown. Um, and the EPA actually in 2015, I think there are tons of organizations trying to inventory where methane comes from. But I think this probably is where fracking comes in. A third of methane emissions, human driven methane emissions, come actually from natural gas and petroleum systems. Um, and then, as you were saying, it also gets into the water, and then you can burn the water.
Yeah, like Josh Fox, the Gasland movies, he made two of them. I watched them
Hmm.
both.
Hmm.
Yeah, that's
Hmm.
pretty extreme when you can burn the water coming out of your own faucet.
Yeah.
Yeah.
Um, and then 18% actually comes from landfills.
Hmm.
9% come from coal mining, 7% come from kind of some other sources like water treatment systems, etc. But actually, almost 35% come from cows and
Yeah.
livestock. Yeah. And so, I feel like we hear a lot about, oh, this is like cows farting or cows burping. But that's actually like very deeply rooted in data. So 10% of all methane emissions actually are coming from manure management. And 25%, so that's what adds up to the 35. 25% is from something specifically called enteric fermentation. And that's bacteria, basically, that is kind of digesting like breaking down the grasses and the plants that livestock that we are raising, our grazing animals, that they produce through their digestion process.
Yeah.
90% of all of that is actually produced by cows, specifically in the form of belching.
Hmm. Yeah. Yeah.
Um,
So we should eat less meat, so that we'd have fewer cows, and that big problem would be solved.
Yes. But the thing is, I think
Yeah.
the US actually is, I don't have specific stats on this. This was something that I
Hmm.
heard recently,
Hmm.
but the US is harboring a very large population of vegetarians. So I think there is a cultural shift
Hmm.
that some people are moving towards kind of eating less meat and becoming more veggie based in their
Hmm.
diets. But a lot of emerging countries are, as their standards of living go up, meat then becomes more attainable. And so, livestock ends up, even if we reduce it, it is just going to get passed along. And, you know, it's not even just meat, it's dairy products, it's your yogurt, it's, your, I don't know. I don't think chickens actually, I don't know if they
But
contribute that
probably,
much, but
I know pigs certainly do, so probably chickens.
yes.
Yeah.
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 And so there are some really innovative ways. This has been known for a very long time, specifically for manure that, it's releasing methane. As Bernie, you were talking about, it's CH4 comes from decomposition processes. And so, manure, your cow poop is also a huge source of your methane. Again, it was 10%. But there's a lot of organizations who have developed ways to capture that methane. So one that was interesting was Wageningen University. They're in the Netherlands. So they talked about how manure from cows can be fermented with the aid of additional bacteria. And this process can produce some biogas and takes place in this. It's something called a digester, but it's there's no oxygen in it, and it's filled with manure on a daily basis. And the manure basically stays in this digester for about 60 days, where that organic material is then converted into biogas. And the gas in that digester contains approximately 50% methane and 50% CO2. And then you got to separate the CO2 from the methane, which can be separated using kind of like filtration systems or like membranes. And so biogas is like pressed through a mesh where CH4 is smaller than CO2, and so they can then be separated. CO2 from cow poop can then be used to create your soda, or stimulate plant growth,
Same
greenhouse.
CO2.
Yes.
Yeah.
Um, so, just imagine your Coke or your Pepsi says, CO2 recycled from cow manure.
Yeah, you wouldn't be drinking that anymore.
I mean, technically, we recycle our sewer water. So,
Oh, I know, yeah. So
yeah.
you could
That's
give it
what
away.
like, yeah, that's what Aquafina and Dasani are. They're essentially tap water that potentially comes from your sewage that has been cleaned and, minerals added and da 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 da. So anyways,
Mhm.
methane can also be used as an energy source to power a farm. It is also actually one of the cleanest fossil fuels. So coal produces about a kilogram of CO2 per kilowatt of energy, kilowatt hour. Oil is about zero point 0.8 kilograms, and then methane is almost half that at zero point 0.5, point 0.5, point 0.6. And so when you burn methane, you're adding oxygen, so CH4 plus O2. It actually does break down into carbon dioxide and H2O. So you can't avoid the carbon dioxide production, but I guess, what we're saying is that it seems like carbon dioxide is better than methane in terms of curbing
Yeah,
warming.
not as
But
powerful. Yeah.
yeah. And so again, it releases about 25% less CO2 than burning the same amount of say coal or whatever. Um, so one thing too that's interesting is, we talked about how landfills contribute about 18% of methane.
Mhm.
If you live here in southern Maine, some of your waste might be collected by EcoMaine. And so they operate a landfill. And, it always baffles me, Bernie, that
Yeah.
we just dig holes and throw trash in there.
Mhm.
Um, but EcoMaine, they actually have a facility. It's called Waste to Energy Plant um, Facilities, I guess. And They actually take in about 175,000 tons of trash a year, which generates about 100,000 megawatt hours of electricity annually, which that is enough actually to power their operations, their vehicles, and 15,000 homes a year.
Hmm.
And so they essentially convert trash to energy, which also leaves kind of reduces volume by about 90%, and and they don't have to kind of keep expanding in land just to like fill it with all of our trash.
Yeah, like parts of
Um,
New York City there.
right.
Killed landfill, I've seen that. Huge mountains.
Yeah. Yeah. No, I used to drive by it when I lived in Georgia. There was like this giant,
Yeah.
huge acreage of just, mountains. You're like, "Oh, what's that?" It's like, "Oh, that's trash."
So,
Um, so EcoMaine actually has 274 acres of the ash that is produced from that waste to energy process. So kind of cool. They harness that methane for good.
mhm.
Bernie, what are some other sources of methane that you came across?
Well, those are the main sources. I mean, obviously, there's some natural ones too.
Hmm.
Some people are saying that the permafrost could be a big issue, and some scientists saying it's pretty safe for a long
Yeah, right.
time. But just the melting of like the ice sheets in Greenland, I found some interesting numbers of how fast that's going. It's over 250 billion tons of ice per year melting just from that Greenland ice.
Wow.
So, I mean, they showed all these images of that happening. That's something we're accelerating, but
Yeah,
not really a source per se, but that's some of the effects of all that
right, right.
CO2 and water vapor.
Exactly. That's that cycle that is just gonna get worse and worse. So one other thing though that is, I don't know if this is a good thing or a bad thing, but it is a thing. So methane in space. Methane as an organic molecule, it's primarily produced by living organisms, and as we mentioned, by burping cows. Um, on Mars, however, its detection has been kind of a mystery. And this was actually kind of recent, July of this year. So, Curiosity, NASA's Curiosity, the rover, has actually picked up tiny traces of methane many, many times as it's kind of traversing its, 5 miles a day, or I don't know how far it goes.
Not that far.
That's even too
Much
far.
less than that. Much
Yeah.
less.
And so they kind of weren't really sure like where the methane was coming from. Was it like a geological process? Could it indicate presence of life? So I think we are excited like, oh, there's methane. That means somebody is burping or pooping or
There's
I don't
no
know.
cows on Mars. That's pretty certain.
And so as I express, scientists could be really excited about that. But the data is really confusing because higher in the atmosphere, the European Space Agency, so the ESA, actually has some orbiting technology. I don't remember the name of the orbiter, but anyways, this orbiter can, so here on Earth, we actually have satellites that can detect what's in our atmosphere, and so same kind of thing there. And they haven't detected methane, no methane at all in any concentration on Mars. So like, what's up with this? And so I think NASA is trying to figure out like, well, is it like coming from the rocks that we're crushing and then it's like kind of dissipating? Is it from materials that we've brought? Like where could it be coming from? And so as it turns out, the little plumes of methane that NASA describes, measured by Curiosity, aren't just kind of discrepancy, or not just flukes, I guess. Um, the discrepancy actually boils down to the sun. So, as we mentioned, methane doesn't last very long. It can kind of break down pretty quickly. But what they found, the Curiosity team found, was that methane on the Martian surface, can actually ebb and flow with the time of day. And so the Curiosity instrument that detected methane actually detected methane mostly, it operated mostly at night or on Martian night. And this is when kind of the atmosphere is a little more still. And so methane doesn't really rise and dilute into the atmosphere like it does during the heat of the day. I mean, Mars doesn't get that hot, but it during the day when the sun is hitting the surface, it will rise. And so um, the ESA's orbiting instrument, which it actually needs sunlight to work, wouldn't be able to detect it.
Hmm.
And so the research team then started to collect measurements of methane over the course of 2 days, um, which they had curiosity didn't really do in the daylight. And then they took measurements at night. And they did actually see that the seeping methane sat near the surface of the planet at night and then dissolved into the atmosphere in the day. So that kind of explained that discrepancy. So that's kind of cool.
Yeah.
And
But you still
then,
don't know the source of it.
yeah, we don't know the source of it yet.
Yeah.
Just know that it is coming up. And, maybe it is that, curiosity is crushing some rocks. And so the rocks
Yeah.
are like
Just rocks.
expelling some methane, but who knows? Um,
Ancient seabeds from way back with the same way it formed on Earth billions of years
right.
ago. So that
Right.
that would make sense.
Could make sense. Yeah.
Well, it could prove that Mars had life then billions of years ago.
Yes, it's true. That's
That
true.
yeah, yeah.
And then the last thing that I wanted to just highlight, and I am not going to explain this very well. I was not a mechanical engineer. I don't really know engines that well. But beginning in development 2009, SpaceX actually had this program called, or still has this program called the Raptor. And this is an engine, or the Raptor engine. It is intended to be used in both the stages of the two-stage to orbit super heavy lift Starship system launch vehicle, which essentially would supersede the Falcon 9 and the Falcon Heavy. So if you hear about Starship, in any SpaceX news capacity, that would be the system that this engine is intended to be used as a reusable rocket engine. And in engine speak, if you have seen any rockets launch, you'll see that the preburner basically exhausts a lot of this dirty exhaust, like black exhaust. And there's, just to break it down really simply, there's really different engine designs. And the Raptor engine is basically an attempt to make a very highly efficient engine with a closed cycle or stage combustion cycle engine. And it's called this like full flow staged combustion cycle, which basically allows us to have a very fuel rich and a very oxygen rich pre-burners, two of them, that pump all of this into the engine to basically make it as clean as possible and to use everything as possible so that we don't have any kind of dirty stuff coming out. And so the only reason why this is in today's show as well is because this is a methane fueled engine that they began testing in 2013. And because of the presence of water and carbon dioxide on Mars, so water underground and carbon dioxide in the atmosphere, methane could easily be synthesized on Mars using the Sabatier reaction. And this essentially says that we can combine CO2 and hydrogen at semi-high pressures and very high temperatures of 3 to 400 C, and that will produce methane and water. We got to bring the H2, the hydrogen, but that's okay because it's fairly light. But we got to bring that, and then we can kind of do all this stuff and make a whole bunch of stuff on Mars, including methane, which can help fuel these engines and kind of do our back and forth missions. So, anyways, SpaceX is ultimately trying to develop a system that is capable of taking humans out to Mars and back over and over and over again. And this Raptor engine is one of the ways to make it. And, as a fuel, we've mentioned it very briefly before, but methane is very efficient. It's very clean. It makes for, allows for the engine to be highly reusable. And because it burns relatively cool, it also helps expand the lifespan of the engine itself as well. Sorry. And it's fairly cheap, I guess, and fairly easy to produce and can be produced on the surface of Mars. So anyways, methane, kind of both a terrible thing, but also kind of a cool thing. And we can apparently do a lot of really cool things with it. And that's our show for today. You've been listening to Scientifically Speaking here on WMPG with myself and Bernie. Stay tuned for Disco Jams with Jam Lewis from 1:30 to 3. And from your favorite nerds, just remember to vaccinate, mitigate, and we can all congregate.